Good morning, dear students. Today we will discuss non-parametric statistics for test of differences. In our last presentation, we discussed test of differences for bivariate test when we were using interval and ratio data, right? When we use interval and ratio data, I already told you that these are basically used for parametric test as well, right? We will be using parametric test only if the data is either interval or ratio scale, though there are certain other things also which need to clarify after this particular clarification, but still if data is not interval or ratio scale, that means we will be using non-parametric test. So when in case of interval and ratio data, to check differences between two independent groups, we were using independent group test, t-test or z-test. But in case when we have ordinal data, to check the differences between two independent groups, we will be using either Mann-Whitney test or Wilcoxon test. And in the same way, differences among three or more independent groups were analyzed using one-way ANOVA. And when it comes to ordinal data, we will be using Kruskal-Wallis test in case of checking the difference between three or more independent groups, right? We have discussed these two analyses in our last presentation. Now we'll be discussing Mann-Whitney test, Wilcoxon test, and Kruskal-Wallis test. For that, we should know what non-parametric statistics are. Generally, for non-parametric statistics, also we will be going for normal p-values and everything. But the only thing is this is distribution-free statistic. When it comes to parametric statistics, we were using we were trying to say that this distribution should be normal, right? There should be a normal curve. But when it comes to non-parametric statistics, it is not necessarily to be a normal curve. It should even if it is not normal, it is non-symmetric, it would be okay with non-parametric statistics. Then are all the variables normally distributed? Some variables are are calculated as per interval and ratio scales. Are these all normally distributed or not? Sometimes they are not. But when it comes to non-parametric analysis, you do not have to check this whether they are normally distributed or not. You can simply start with the analysis. You can simply start with your non-parametric statistics if you know that you have collected the data through your ordinal scale, not through the interval or ratio scale. Three basic non-parametric tests we'll be discussing in this particular presentation are Wilcoxon matched pair sign test, Mann-Whitney test, and Kruskal-Wallis test. These two tests are basically Wilcoxon matched pair sign test is basically used in place of paired t-test. Mann-Whitney test is generally used in place of independent t or z test, and Kruskal-Wallis test is used against ANOVA of parametric test. So let us discuss them one by one. Wilcoxon matched pair signed rank test. The Wilcoxon matched pairs rank test is used to determine differences between groups of paired data when the data do not meet the rigor associated with the parametric test. So there is basically one condition to check Wilcoxon matched paired sign rank test, that your data should be collected before and after. If it often involves the use of matched pairs, for example, before and after. For example, I want to check whether companies when they were not reporting CSR, their profitability, and after using CSR, their profitability. For example, CSR, Corporate Social Responsibility Act came in 2013 through Companies Act. It was said that CSR has to be necessarily done by companies having so and so profit and so and so turnover. 2% they have to spend on corporate social responsibility, right? Before 2013 also companies were doing CSR, but not every company was doing corporate social responsibility. So I might check whether profitability was more before using CSR, before doing something for CSR, or it has increased after they have done CSR. So I might check it this way, like before CSR has come into the picture in 2014. Companies did not start following this particular law because it has come, the law has come in the last 2013, and it was about to end. The financial year started from April 2013 to March 2014, and the law should be implemented. It was stated that from 1st April 2014. So I can do one thing, for those companies especially which were not reporting about corporate social responsibility, which were not doing corporate social responsibility, but were coming under the list which should have done corporate social responsibility. I can do one thing. I'll be collecting their profits data before coming the law on CSR, that is 2014, 2013-14, March 2000, April 2013 to March 2014, and then April 2014 to March 2015. I can collect 2 years data and check whether before it was better or after it was better, right? So this is also a kind of thing. Or you might check effect of a medication. Before medication, what was the condition, and after medication, what happened, right? That is also a kind of before and after. So Wilcoxon matched pair test, rank test, basically tells you whether something, some test you might have checked was efficient or not. Yeah, and this can be related with pre-testing as well. Sometimes in companies these days, they do go for pre-testing for the employees, and then after the workshop has been completed, workshop for anything for their value addition has been completed, they'll be giving them the same test, and will check whether they have improved their skills or not after the whole workshop. Before also the same test was given, and after also the same test was given. Then I'll know whether, if employee has scored 20 marks before and 40 marks after the workshop, that means the employee has improved a little, right? After out of 100. So we'll take it, we'll understand it with the help of this example. For example, managers before score was this and after scores were this after the workshop, right? So you'll be calculating the sign of difference first. What was the sign? Here it is increased. Here also it is increased, decreased, and then increased. Like if the score has increased, you will be assigning plus sign, and the score, if the score has decreased, you will be assigning subtraction sign, negative sign, you can say. Then we'll be checking the absolute differences as well. Here absolute difference is 15, here absolute difference is 3, here absolute difference is 1. We'll be calculating all the sign of differences and absolute difference for all the values, and after that we'll be ranking them as per the values, not as per the signs. We will not check the sign now for the time being. While calculating the rank, we will just assign the rank 1 to the lowest value and higher to the highest value, right? One would go with absolute difference 1. Then if there is another value 2, absolute difference for rank 2, then we have got 3 value for 2 managers. That means they'll be sharing a score. So it can be like 3 and 4. They both have third and fourth rank. So we'll be calculating the mean of 3 plus 4, and it would turn out as 3.5 and 3.5. We'll be assigning 3 point value to both of them. Then there's a value called 4 and 4 2 times again. That means rank 5 and rank 6 will again calculate the mean, and it would be 5.5. And we'll assign the value 5.5 to both the managers having the difference of 4. Then 5, there is only one absolute difference of 5. Then it is 7th rank. Then 6, only one, that means 8th rank. Then after that it is 8, that means ninth rank. Then is there any value? 9, 10, 11, 12? No, no, no. Then there is absolute difference value of 15, that means 10th rank. And now we'll be seeing these ranks as positive and negative separately, and then we'll be calculating the sum of these ranks, right? Positive, all the positive ranks would be coming under positive, and negative under negative. Then we'll be calculating these values, we'll be submitting all of them, right? And now on that basis we'll be calculating the critical values for the analysis, and then we'll see whether it is significant or not, right? As per the level, 5%, maybe 2%, 1%, 10%, that depends on you, right? Then there is Mann-Whitney U test. Mann-Whitney U test is a distribution free test again, like all the non-parametric tests. And this is done for two independent samples, like we were doing Wilcoxon test for paired comparison. As the name also suggests, it was paired sign rank test, right? So it was just telling us we are doing this particular analysis on pairs, then we'll be calculating the signs and we'll be ranking the whole thing, right? And we did all of them step by step. Now Mann-Whitney U test is basically for independent samples, right? Suppose we have got two independent groups, group 1 and group 2, with N1 and N2 observations respectively. So test statistic would be equal to sum of the ranks of smaller group, or if N1 is equal to N2, then smaller of the two sums would be taken up. And that would be our test statistic. So let us discuss it also with the help of an example. The following data indicate the lifetime in hours of samples of two kinds of light bulbs in continuous use. This is brand A and this is brand 2. Brand A bulbs had been, randomly taken randomly taken the values of brand A bulbs. And for example, bulb number 1, it continued, its life was 603 hours. Then bulb number 2 in A, its life was 625 hours. Like this, we have mentioned all the hours, and for B also. So now we are required to use the Mann-Whitney test to compare the lifetimes of brands A and B. What will we do? We will be assigning the ranks to all the variables like this. We have just mentioned all the lifetimes in ascending order. For example, shorter life here is 580, I think. Then it is 585, then 590, then 593. This way we'll be using these values in ascending order, like this: 580, 585, 590, 593, 600, like this. And we'll be assigning the value of group here. After checking it from here, like whether the value was from group A or from group B, we'll be assigning all the values, and then we'll be ranking these all these groups, all these sample scores like this. Now, as we mentioned here, that sum of ranks of smaller group would be your test statistic, or if N1 is equal to N2, then smaller of the two sums would be taken, right? We will be summing all the ranks of A separately and all the ranks of B separately, and then we'll check whether these are same or different. If these are same, then we'll be calculating the values of rank, we'll be summing them, and then we'll go with test statistic like this. H1, that means null hypothesis here is mean of ranks assigned to the values in the two groups are same, and H1 says means are not same. So test statistic U would be equal to N1 into N2 plus N1 into N1 plus 1 divided by 2 minus R1. R1 is the rank of smaller group here. N1 and N2 are the observations in group 1 and group 2. For example, here in brand A and brand 2. So R1 here was 128, and so we'll be calculating U as the same, like we know that we had taken both the brands in equal values, like I had chosen 12 bulbs of brand A and 12 bulbs of brand B, so the N1 and N2 are same, and then the value would be 94. Test statistic value is 94. The critical value of U for N1 and N2 each equal to 12, and for 0.05 level of significance is 37. Since the critical value is smaller than 94, that means we will be accepting the hypothesis. If it was not, then we will reject the hypothesis. So that's it. Normal approximation: when N1 and N2 greater than 10, the sampling distribution of U statistics can be approximated by the normal distribution as well. And then mean would be equal to N1 into N2 divided by 2. That means 72. And standard error would be calculated as N1 into N2 multiplied by N1 plus N2 plus 1 divided by 12 whole the square root, and this comes out to be 17.3. And statistics minus mean divided by standard deviation would be the normal approximation value now, and that is 1.27. Now, Kruskal-Wallis test for several independent samples. Till now, we were discussing the test for 2 independent samples and 2 dependent samples. But basically, we were trying to take the categories, 2 categories only, right? Now, we can have more than 2 categories, more than 2 groups. Basically, we say more than 3 or more than 3 groups here. When a researcher wishes to compare 3 or more groups of population, then Kruskal-Wallis test is the most appropriate statistical technique. And the test statistic used for this is basically H statistic here. As with all non-parametric tests, assumptions are non-restricting. You can use any kind of data or any kind of ordinal data, all ranking data. The researcher does not have to assume that the underlying population are normally distributed, just like all the non-parametric tests, or that equal variances are shared by each group. We do not have to assume anything. We will just have 3 groups and we'll start the analysis to check the differences. Here we can state things like this. The null hypothesis is population 1 is equal to population 2 is equal to population 3. So Kruskal-Wallis test is a technique to determine if the 3 populations have same distribution shape or dispersion, right? So we'll be calculating the values with the help of this formula. H statistic used for Kruskal-Wallis is equal to 12 divided by n into n plus 1 multiplied by summation of rj square divided by nj minus 3 into n1 n plus 1, where R basically is the sum of ranks for the JF group, and N is total sample size, and whereas NJ is the sample size of JF group. That's it for Kruskal-Wallis. You can have a look at this table while going for hypothesis testing when regarding parametric and non-parametric test. Parametric tests are 1 sample, 2 samples. 1 sample test basically are T test and Z test, that too on the basis of less than 30 sample size and more than 30 sample size. Then 2 samples, when there are 2 samples, then there are tests like independent and paired samples. For independent samples, we have got 2 group T test and Z test again, and for paired samples we have paired T test. In case of non-parametric test, for 1 sample we have chi-square, Kolmogorov-Smirnov test, Run's test, and binomial for all 1 sample against T test and Z test. Then when it comes to 2 sample test, for independent samples we have chi-square, Mann-Whitney test, median, and Kolmogorov-Smirnov test. And for paired samples, we have sign test, Wilcoxon, McNamara, and chi-square. Maximum we use Wilcoxon and sign test here. Done. This is all about bivariate analysis, univariate and bivariate analysis. 1 sample means we are talking about univariate analysis, and 2 samples means we are talking about bivariate analysis. That's all. Let us discuss some self-assessment questions. Explain Mann-Whitney test. It is used against which parametric test? Mann-Whitney test, you will be explaining it with the help of definition, then the formulation. You can take one example as well as per the number of as per the questions marks, and then it is basically used against t-test. So you can mention that also, and you can do some comparison among them, because t-test is used for parametric data, and for that you have to check the distribution as well. For Mann-Whitney, you do not have to check both of them. Then second is explain Wilcoxon test step by step. Write the definition of Wilcoxon test, why it is used, write the formula, and take one example, and explain it point by point. Like first you will be calculating, will be arranging the data, then you will be calculating the ranks, positive, negative, and you will be using the formula. Everything you can mention. Then list the practical steps for interpreting results for Kruskal-Wallis test. Practical steps means you will be explaining it with the help of formula, the complete formula, and you will be explaining with the steps. Like first you will be calculating N1, then N2, then RJ, and then you will be calculating that with the help of formula. Then you will decide whether to accept or reject the hypothesis, right? That's it. In our next presentation, we will be discussing bivariate analysis for measure of associations. In last two presentations, we have discussed bivariate analysis only, but that was for test of differences. We were trying to check the differences between two or more groups. Now, when it comes to measure of association, we are basically trying to check association among two variables. Right? When you check association among two variables, basically we use correlation and regression analysis in most of the studies. For example, you want to check whether two variables are associated with each other or not, then you will be checking, you will be using correlation analysis. Once you know that these two variables are associated with each other, then you can check whether one variable is affecting the other or not. Then for that you will be using regression analysis. Like that we'll be discussing in our next presentation. That's it. Thank you.